Okay, so we are given a matrix here, which is written in a form like this, and we need to find that how these constants or coefficients a0 and a1, a2, a3 are related to the trace of the matrix X and trace of this kind of form, right? So first I'll write the Pauli matrices. So basically sigmas. Say sigma 1 is sometimes this is referred to as sigma x as well. And there is sigma 2, which is defined as 0 minus I 0, sometimes referred to as sigma y. And then there is sigma z, which is defined as, or sigma 3 here, defined as 1, 0, 0, minus 1. Okay, so these are the Pauli matrices. Okay, fine. So what we are given here is that x is equals to a0. Nothing is there, so we assume this is identity. Then there is ak. What is it? Yeah, sigma dot a. Called sigma dot a. So a0 and a plus that is a1 sigma 1. What is sigma 1? It's sigma x. 2 0 psi I 1. So if this all up, first entry here is a0 plus a3. Second entry is a1 minus I a2. Then the next entry is a1 plus I2. The third entry is a0 minus a3. Right? Okay. So what we need to see here first is how is the a0 is related to trace of x. So we'll find the trace of x, which is nothing but the summation of these diagonal elements. So sum this up, you will get 2a0, which means that a0 is half trace of x. Okay, fine. Then we need to find first sigma k x, which is okay, dot sigma 1 x plus sigma 2 x plus sigma 3 x. Okay, so this will be basically sigma 1 plus sigma 2 plus sigma 3 times x, because we know how we can write x. and we sum up the Pauli matrices. We get there is 1 and minus 1 from the sigma z, and then there is minus I here, so it will be, yeah, what will it be? 1 minus I, 1 plus I multiplied by A0 plus A3 minus A2. Okay, so when we do this matrix multiplication, what do we have? The big matrix. So it will be A0 plus A3 plus A1 minus I A1 plus I A2 plus I A2. I squared will give me minus 1, so it will be plus A2 plus 1 plus 1. And there will be A1 minus IA2 plus A0 minus IA3 3. Yes, I need to yes, 2. Okay. All right. So can when we take trace of this will be summing up these diagonal elements. So there is A0 plus A3 plus A1 minus I A1 plus A1 minus I A2 plus plus A3. So okay, A1 I A1 cancel, IA2 will cancel, and rest of the things will be saved. So yeah, and also A0 will also cancel. So we'll be left with 2 times A1 plus A2 plus A3. There is A3, A3, A2, A2, A1, A1. Okay, or just to, if one wants to use shorthand notation, you can just be 2 ak. So ak is half heat ratio to x. Okay, seems fair. Now next we need to find we need to find we need to obtain a0 and ak in terms of matrix elements aij. Okay, so suppose one writes x as x11, x12, x21, x22, then we have shown that how we can write x0 in terms of Pauli matrix is, and this will be 0 plus a3, 0 minus a3. So if you want to compare x11 equals to a0 plus a3, x22 equals to a0 minus a3, x22 is a1 minus a2, x21 equals to a1 plus a2. So if we sum up these things, to a0, then is okay, can sum up x12 plus x21, so we need to a1 similarly x21 minus x12 give me i's to a2 and i's up x11 minus x22 to a3. So right, a0 is 1 by 2x11 plus x2. Right, a1 is half plus x2. Right, it is 1 over 2i, 2 minus 2. Right, a3 is 2 minus x2. Right, so we found the a0 and all the remaining in terms of these matrix elements. That's it.